Welcome back, ladies and gentlemen. We are still in Chapter 5, and now we are moving on to Section 5.2. This will be the first day of 5.2, and we'll be looking at probability models and basic rules of probability. By the end of this lesson, you will be able to give a probability model for a random process with equally likely outcomes and use it to find the probability of an event. You will also be able to use basic probability rules, including the complement rule and the addition rule for mutually exclusive events. At the end of this, try this assignment. All right, now this first example we are actually doing as an in-class example. So see our work in class for this one. Now this is a short lesson. You can read most of this information on pages 341 to 346, and we're starting with probability models. So what is a probability model? How do you verify a probability model is legitimate, and what is a sample space? Now, for our definition, a probability model is a description of some random process that consists of two parts: a list of all possible outcomes and the probability for each outcome. All right, so as you can see up here, when you randomly select a student who took the 2015 AP Statistics exam, there are only 5 possible scores, 1, 2, 3, 4, and 5, and then the probability of each score is identified below. So it listed all possible outcomes, and then the probability for each outcome. Now, something for you to remember, all probabilities are between 0 and 1, and the sum of the probabilities in a probability model equals 1, because it should represent all possible outcomes, and 1 represents a probability of 100%. The probabilities are identified as proportions unless we choose to identify them as percents. So they're initially calculated as proportions. That's why it's between 0 and 1 instead of 0 and 100. Now, another definition you need to know is that the list of all possible outcomes is called the sample space. Right? Now, a probability model does more than just assign a probability to each outcome. It allows us to find the probability of an event. Now, with that in mind, what is an event? Right? The definition, an event is any collection of outcomes from some random process. So if we wanted to look at the probability that a chosen student scored a 3 or better, we're looking at this block right here, the 3, 4, and 5. Right, so the event is any collection of outcomes from some random process, and the probability model allows us to find the probability of that event. Now, the complement rule. The definition is that the complement rule says that the probability that A did not occur is equal to 1 minus the probability that A did occur. So not A, it almost looks like you have an exponent of C, so A to the C, is the complement of the event A. So this we state as not A. Right? So that is the event that A does not occur. So probability that A does not occur is equal to 1 minus the probability that A did occur. Now, what does it mean if two events are mutually exclusive? And what is the addition rule for mutually exclusive events? So two events, A and B, are mutually exclusive, in other words, disjoint. So we use these two terms interchangeably. If they have no outcomes in common, and so they can never occur together, that means that the probability of A and B is equal to 0. Right? They cannot happen at the same time. You cannot be both a freshman and a senior at the same time. Now, you could be in, let's say, pre-calculus and AP statistics at the same time. I've had students who have taken both classes before. You could be a junior and an AP statistics student, right? Those are not mutually exclusive. Now, being a freshman and an AP statistics, you cannot do that. The addition rule for mutually exclusive events, A and B, says that the probability of A or B is equal to the sum of both probabilities. Now, this is because the intersection cannot happen. And this addition rule is specifically for mutually exclusive events. There's a different addition rule that we use for more general events when the events are not mutually exclusive. So be careful. This is not the only addition rule that we have. Now, if an example of this is if you roll a die once, the probability that you will roll a 1 or a 2. You can't roll both because they're on separate sides of the die. If you only roll the die once, you only have one face that you're looking at. So you have two different outcomes that would be considered successes, but they can only one or the other could happen. You couldn't have a 1 and a 2 in only one roll. All right, so the 1/6 likelihood for roll 1, for rolling a 1, 1/6 likelihood for rolling a 2, those would be added, giving you 2/6, which is also 1/3. All right. Try these problems, and we'll see you in class.